Hello friends, myself Prashant Patil. Today we will see new topic of subject data structure. The topic name is searching and sorting. Before starting a new chapter or new topic, just we recall the previous lecture points, which are hashing or definition of hashing, then types of hashing and different hash functions. Today we will see in this lecture some points which are listed here. The first point, which is searching or definition of searching. Then we will see categories of searching. Then we will see types of searching. The first point is that searching or definition of searching. Searching refers to the operations of finding the location of given element or item is called as searching. Basically, searching means to find a particular element in the given array, which is called as searching. Basically, searching is an operation, or this is one technique that helps to find the place of a given number or value in the list or in the array. Any search is said to be successful or unsuccessful depending upon whether the element that is being searched is found or not. If suppose element is present, then we will say number is found successfully, otherwise not successfully. Some of the standard searching techniques that is being followed in the data structure is listed. Basically, various searching techniques, the process of identifying or finding a particular record is called as searching. You often spend time in searching for any desired item. If the data is kept properly, is sorted order, then searching becomes very easy and efficient. You will get to know the basic concept of searching that are used in the data structure and case of programming also. Now here we can see now we will see here two categories of searching. The first category is internal searching and the second category is that external searching. First we will see internal searching. Searching method in which all elements remain constantly in main memory or primary memory is called as internal searching. Suppose if you want to do searching inside a main memory, then we can call it internal searching. Why they call it internal searching? Because whatever we search here, the search elements are kept small or kept in a main memory or primary memory, which is called as random access memory, because its size is too short. That's why this sorting done inside a main memory or primary memory. The second one is that external searching. Searching method in which elements are kept in secondary memory or secondary storage are called as external searching. Basically, external searching done inside a hard disk. Why external searching done inside a hard disk? Because the size of the list or size of the elements are too large as compared to the internal searching. That's why this searching done inside a hard disk or secondary memory or secondary storage, so which is called as external searching. The next point, which is types of searching. The first type of searching is linear search, or which is called as sequential search. A linear search sequentially checks each element of the list until it finds an element that matches the target value. If the algorithm reaches the end of the list, the search terminates unsuccessfully. In linear search, the search value is compared with first location. If suppose matches is done, then we will display the result. Otherwise, we will go to the next memory location. Likewise, we will check the search value to all the memory locations which are present in the array. Basically, linear search is the simplest search algorithm that is called sequential search. Why they call it sequential search? Because the search element is compared from 0th location up to the last location. In this type of searching, we simply traverse the list completely, means every time we have to search from location 0, location 1, 2 up to the last location, and matches each element of the list with the item whose location is to be found. If the match found, then location of the item is returned, otherwise the algorithm returns the null value. If suppose number is not present in the given list, then this algorithm or this method returns the null value, otherwise it will return the location of this particular item. Basically, linear search is mostly used to search an unsorted list in which the items are not sorted. The main thing is that the linear search is applied on unsorted list. There is no need to take any sorted list here. This algorithm of linear search is as in computer science. Linear search or sequential search is a method of finding an element within the list. It sequentially checks each element of the list until a match is found or not. A linear search runs at a worst linear time and make at most n comparisons, where n is the length of the list. Means we have to check the search element up to the last, from first element to the last element, means nth number of elements. That's why they called worst linear time. If each element is equally likely to be searched, then linear search has an average case of n plus 1 divided by 2 comparisons. But the average case can be affected if the search probabilities of each element vary. Means it depends upon the size of a list or size of an list. Linear search is rarely practically because other search algorithms and schemas such as binary search algorithm and hash tables. A simple approach is to do linear search, that is, start from the leftmost element of the array. One thing just keep in mind, the search element is searching start from leftmost side of the array and one by one compares x with each element of the array. Now here x is the search element and x compare with every location of the array or given list from the left to right. If x matches with an element, then return the index. If suppose search number is present in the list, then it will return the index or it will return the location of the particular element. If x does not match with any element, then return the -1, or which is called as null. If suppose search number is not present in the given list or given array, then it will return the null value or it will return the -1. Now see here one example. Input, the input is 10, 20, 80, 30, 60, 50, 110 and 100, 130 and 170. This is the input which are stored in the array. The name of the array is 8RR. Now here x is equal to 110, means x is a search number. The search number is 110, means that 110 basically search from left to right in the list. As you've seen here, the list of array which is 10, 20, 80, 30, 60 up to 170. The first search value, the first step is that the search value 110 compare with location number 0, which contains the value 10, means 110 compare with value 10. If suppose matches is done, then we'll return the location of this particular element. If matches is not done, then we will go to the next memory location, which is location number 1, which contains the element 20. Now again 110 compare with 20. Yes, number is not present, so we will go to the next location. Again 110 is compare with 80. Yes, number is not present, then go to the next memory location. 110 compare with 30, 110 compare with 60, 110 compare with 50, then 110 compare with 110. Yes, number is present. If number is present, then we will display the or return the memory location of this particular element. Means that this memory location which is 6 means the output which is 6 element x is present in the index 6, means 110 element is present at the index number 6. Now we can see here another one example. Name of the array is ARR, and basically first we initialize some values in the array. Initialized values are right inside a curly bracket, which are 10, 20, 80, 30, 60, 50, 110, 100, 130 and 170. Actually I think all the elements are present in the previous example. Now here x is equal to 175. What is x? Now x is a search element. Now 175 is compared to the zeroth location element, which is 0. As you know that every time the search element is compared with zeroth location, then it will compare with first location, then it will compare with second location up to the last location. This is our rule. The first 175 compare with zeroth location element, which is 10. If 175 equal to 10, yes, condition is false, then go to the next location. If suppose 175 is compared with 20, then condition false, then goes to the next location. 175 compare with 80, no matches is there. 175 compare with 30, no matches is there. Then 175 compare with 60, 175 compare with 50, again 175 compare with 110, 175 compare with 100, then goes to the next memory location. Again 175 compare with 130, then goes to the next memory location. 175 compare with 170. Now list is over. Means that search value 175 is not present in the whole list. That's why it will return the -1, or it will return the null value. So the output will be the element 175 is not present in the given array. This is our final output. Now we will see another one example in the figure, which contains one array. The array size is 9, means location 0 up to the location 8. Total 9 locations are present here, which contains number of values. The values are 10, 50, 30, 70, 80, 60, 20, 90 and 40. Now here find value or the search element is 20. The basic rule is that search value is compared from left to right from the zeroth location. Now here 20 is compared with zeroth location element, which contains the element 10, means 20 is compared with 10, then no matches is there, then goes to the first memory location, which contains the element 50. Now 20 is compared with 50, then no matches is there, then goes to the next memory location. The next memory location is 2. Again 20 is compared with 30, no, then goes to the next memory location. 20 is compared with 70, then no, then goes to the next memory location, which contains the element 80. Again 20 is compared with 80, no matches is there, then goes to the next memory location. 20 is compared with 60, then goes to the next memory location. The next memory location is 6, which contains the element 20. Now if 20 is equal to 20, yes, condition is true, means 20 is found at the location number 6. This is our final output. Now we can see here one program of linear search or sequential search. Now we can see here one function is there. The name of the function is search, and the return type of the function is integer, means this function return some value to the function calling statement. In the function contains 3 parameters. The first one is the array, the second one is the n, and the last one is the x. Array n and x. In the function definition contains some members. Now we will see the function members which are listed here. First member is integer I. I is the integer type variable. Then we can see here one for loop. For I equal to 0, I is less than n, and I plus plus. Now n is a size of the array. Now we can see here the size of the array is 5, means a integer array of 5 is equal to 2, 3, 4, 10 and 40, means these 5 elements are stored in the array ARR. Means here n is 5, means this for loop will be executed 5 number of times. Inside a for loop which contains one if condition is there. If array of I is equal to x. Array of I means array of 0. First time array of 0, second time array of 1, next time array of 2, array of 3, array of 4 is equal to x. X is a size of an x is a search element which compare with every location. If suppose element is found, then return I. Return I means return the location. Otherwise it will return the -1. -1 means it will return the null value. Now we can see here in main, in void main or int main, first we declare one array. Name of the array is ARR with size 5. Now we have to initialize 5 number of values to this particular array. Is equal to in curly bracket 2, 3, 4, 10 and 40, then curly bracket close. These 5 values are initialized to the array, means 5 values are stored in the array. The size of array is 5. Now next line, integer x is equal to 10. Now x is the integer type variable which initialize the value 10, means here 10 is considered as search value. The next line, which is n is equal to 5. Now 5 is size of an array. Then again we declare one variable. The name of the variable is result is equal to search in bracket ARR comma n comma x bracket complete semicolon. This statement is called as function calling. When we call the function, then directly jump into the function definition. Now we will jump into the function definition. Now see here carefully, in the search, this is one function definition. Inside a function definition which contains 3 number of parameters. The first one is the array, then n, and then last one is the x. Now here when we call the function, then it will goes to the function definition in the previous slide. The first parameter is array. The array contains the 5 number of elements. These 5 number of elements are stored in the array ARR. Again, comma n comma x. What is the value of n? N is the 5. 5 is the size of an array, and the x is the search value. These values are stored in variable int n and int x. Means that n is a 5 and x is a 10. Now here calculate the for loop. Now here for loop will be executed 5 times. For I is equal to 0 means I is initialized to 0. Then check the condition. I is less than n means 0 is less than 5. Yes, condition is true. Then goes to the next statement. The next statement which contains if statement. If array of I means array of 0. Array of 0, the value contains the 2. Means 2 is equal to x. X is a 10 means 2 equal to x. Yes, condition is false. Then goes to the for loop. Now again I plus plus. I will be incremented by 1. Initially I is set to 0. Now I will be incremented by 1. Means I become a 1. Means 1 is less than 5. Yes, condition is true. Then goes to the next statement. In next statement, if array of I means array of 1. Array of 1 which contains the element 3. Means 3 is equal to x. X means 10. 3 equal to 10. Yes, condition is false. Then again I plus plus. I is incremented by 1. The previous I value is 1. Now I becomes a 2. Now check the condition. I is less than n means 2 is less than 5. Yes, condition is true. Then goes to the next statement. The next statement is if condition. If array of I means array of 2. Array of 2 means which value? 4. Means 4 is equal to x. X is a 10. Means 4 is equal to 10. Condition false. Then goes to the for loop. inside for loop, again I is incremented by 1. Now I become a 3. 3 is less than 5. 3 is less than 4. Yes, condition is true. Then goes to the next location. If array of I means array of 3 contains the element 10. Array of I means array of 3. Array of 3 means the value 10. 10 is equal to x. X means 10. Means 10 is equal to 10. Yes, condition is true. Then goes to the next statement. The next statement is return I. Return I means it will return the memory location which the element will be stored. Means here 10 stored at the location 3. Now here this function return one value which is 3 or the location 3, and this location 3 value stored into the result variable. Means here result is equal to 3. Now check if result is equal to -1. Now this is one conditional statement. As you know that the result contains the value 3. 3 equal to -1, condition false. Then goes to the next statement, conditional statement, which is printf element is present at the index 6. Result is 6. Means the element 10 is present at the index 6. This is our final output. Thank you.